Hello, ladies and gentlemen, and welcome back to more of the 2013 Hypatia contest. Thank you for joining me. We're on question number 4, the very last question in the contest. And we got 3 parts here, a light bulb, a written, and a written. Have they been doing that the whole time? No, there were more light bulbs earlier, but I know question 3 was like that. Anyway, for A, let's just ease ourselves in. Just a light bulb, 20 cubes, each with edge length 1 centimeter. Are placed together in 4 rows of 5. What is the surface area of this rectangular prism? Fantastic question. In fact, what's the surface area of a rectangular prism, period? Okay. So, let's take a look. I'll just draw a very quick rectangular prism. Surface area can be determined by the length, width, and height. I wouldn't go into this normally, but it's a very quick formula, and if you haven't seen it, it's quite useful. Maybe not for the remainder of this question, but it's still something you should know. And I find surface area tends to be neglected, even though when you get to things like calculus, you need to know surface area, even of rectangular prisms, for optimization problems. Anyway, so we often know that volume is length times width times height, but surface area is just the sum of the rectangles on the sides here. So that's going to be a length times a width for the base, but also another length times width for the top. So there's going to be 2 of those. And there's going to be a width times a height for this front face, but there's also one in the back that also gives us a width times height. So there's 2 of those. And finally, we pair the last 2 dimensions, a length times a height, and that gets us surface area. So in particular for this one, it's a 1 by 4 by 5. We can either see that by inspection or drawing it out. But you can sort of count 4 across, 5 across, and then it's 1 high. So our surface area is going to be 2 times 1 times 4, plus 4 times 5, plus 5 times 1. So that's going to be 2 times 4, plus 20, plus 5. That's 29, so it's going to be 58. And that would be our final answer. Surface area of 58. Did they give us something like centimeters? Yeah, centimeters, so you could say 58 centimeters squared. But the units aren't really that important. What's important is that we do the calculation properly and we get the numbers. And we wrote out our formula as well, so even if we bombed the rest of the question and even got that 58 calculation wrong, we did write out how we did it. So a light bulb, they should give us some part marks, at least. All right, so that's A. That was actually pretty short. B part. A number of cubes, each with edge length 1 centimeter, are arranged to form another rectangular prism, having a height 1 centimeter, just like in part A, and a surface area of 180 centimeters squared. Determine the number of cubes in the rectangular prism. Interesting. So the number of cubes is something that we can... I would have thought with only knowing the surface area quite vaguely like that, there'd be a certain number of possibilities for length and width. Oh well. We know it's going to be height 1 centimeter. We don't know the other dimensions. If we knew the other dimensions, we could tell what... Just like we know there's 20 cubes, because this is a 1 by 4 by 5 here. But just knowing surface area is enough? All right. Okay, so, let's let length times width times 1 be the dimensions of the prism. So let's state right off the bat that length times width is the number of cubes, and that was what they asked for, right? State the number of cubes in the rectangular prism. So we know that 180 is equal to the surface area is equal to twice, and now it's going to be 1 times length plus length times width plus width times 1. So that's going to be 2 length plus width plus length width. Okay, so dividing by 2, 90 is length plus width plus length times width, and Now, let's factor out a length. So we'll get length and then width plus 1. Plus another width. Well, this looks awfully similar to length plus 1 times width plus 1. Right? Because that's length times width plus width plus 1. So, minus 1. So 91 is length plus 1 times width plus 1. Now, that means that since L and W are integers, positive integers, you're going to have to, L plus 1 and W plus 1 are going to have to be factors of 91 here. But 91, so we could either have 1 and 91, and I'll explain why this won't work in a moment, or 7 and 13. So there really is only one possibility. It doesn't matter which one L and which one W are, because the length times width calculation is all we care about. So L plus 1 can't be 1, since that would imply that L is equal to 0, which is ridiculous. How can I have 0 cubes in one direction? So that tells me L plus 1 is 7, W plus 1 is 13. You could probably say something like without loss of generality, but it doesn't really matter. Therefore, L is 6, W is 12, LW is 72. There are 72 cubes. Okay, that actually wasn't that bad. I didn't think there'd be a unique solution, but I guess I got to be a little more trusting when they make these up. Okay, last part of the whole contest, C part. The number of a number of cubes, each with edge length 1 centimeter, are arranged to form a rectangular prism having length L and width W and thickness 1 centimeter. Just like the last couple. I wonder if surface area will be involved. I'm betting we take a chunk out just based on the picture. A frame is formed by removing a rectangular prism with thickness 1 located k centimeters from each of the sides of the original rectangular prism as shown. Each of L, W, and K is a positive integer. Gee, I would hope K. Actually, they all have to be positive integers, otherwise how would you do it with these cubes? Okay. If the frame has surface area of 532 centimeters squared, determine all possible values for L and W so that L is greater than or equal to W. Okay. So, surface area. Well, we're probably going to have to figure out a formula for surface area of this figure. Now, fortunately, they have given us a whole bunch of information. It was a rectangular prism, and then we removed a smaller rectangular prism. So we might be able to recognize the surface area as a difference between some surface areas or something like that. Yeah, I think that should be our first goal. Get a formula in terms of L, W, and K for this 532, this surface area. And then I don't know where we'll go from there because we don't have a whole lot of extra information. Now, I suppose technically we could argue that W has to be more than 2K. Because otherwise, how would you get in K centimeters on both sides? And if W is bigger than 2K, L has to be, because we got L is greater than or equal to W. And this will probably narrow it down, and then maybe just like in B part, we'll have to start looking at factors of whatever number. So maybe we should start thinking of factors of 532 or something like that. But the very first thing we should do is get a formula for the surface area of this weird-looking frame. Okay. So, let's draw a picture of the frame. I'm not quite sure what the best way to go about doing this is. Okay, so notice that for the whole to exist, 2k has to be less than w, less than or equal to L. So 2k plus 1 is less than or equal to w, is less than or equal to L. This might be helpful, or maybe it's this one. I don't know. If we're coming in k on both sides, this is going to have to be w minus 2k. And we'll use a different color here. We'll use green. This is also k, and this is also k. So this whole side here is going to have to be L minus 2k. All right, so surface area is, okay, there's going to be two strips of size L, two L by 1s, two W by 1s. Then there's going to be two of these L minus 2Ks. Two L minus 2k by 1s, and two W minus 2k by 1s. So that covers all the things that are by 1. And then we've got the sides of the frame that we have to work. So these orange things. And they're a rectangle minus a smaller rectangle. And there's going to be two of them. So 2 L times W for the big rectangle minus L minus 2K times W minus 2K for the smaller ones. Alright, so that covers front and back. All the one-dimensional ones have been done. I think we're good. And I would say as long as you have a slightly clearer picture than the one I've got and the formula, that would suffice. You don't have to say, well, I counted these strips, and then I counted these. You only have so much space in the booklet, and as long as you got a picture accompanying it, showing that you know this length is L minus 2k and this is W minus 2k, as long as your surface area is correct, they will accept it and move on. If your surface area wasn't correct, you're going to get dinged a whole lot because you just sort of made an assumption and moved on. You'll still probably get some marks, though. Anyway, so here's our formula. Let us expand it out. So 2L, 2W, plus 2L minus 4K, plus 2W minus 4K, plus 2LW minus 2, and it'll be LW minus 2KL minus 2KW plus 4K squared. Alright, what to do now? 2 L's and this 2 LW and this LW will cancel. Maybe we'll get a quadratic in terms of K we need to solve for. 4L, 4W minus 8K, the minus 2 times minus 2, so plus 4KL plus 4KW minus 8k squared. Okay. Does this work? Well, if I'm curious as to whether or not it works, I should probably also take out a factor of 4 just to make my life a little easier. L plus W minus 2k plus KL plus KW minus 2k squared. I'm also thinking we might want to combine L plus W as a single term. And then we'll have a quadratic in terms of K, I believe. Anyway, so I think this formula will work. I think I should test it. And I will take out the L plus W right now. Okay, so I think that's my formula. Let's just go back and double check. Yes, as far as I understand it, that's my formula. I'm just going to draw a very quick rectangle. I'll do the 4x5. And my k, I will go in by 1 on each side. So the whole inside will be a 3x2. So it'll be 20 minus 6 on the top face, and then 20 minus 6 on the bottom face, and then a 3, a 3, a 4, a 4, a 5, a 5, a 2, and a 2. So that's 14, 14. The 2 3s will become a 6, an 8, a 10, a 4. That becomes a 20, and then those guys become a 30. Those become an 18, which becomes a 48. And then another 8 should be a 56. Now, L and W being 4 and 5, L plus W is 9, so it's 9 minus 2 plus 9 times 1 minus 2 times 4. So it should be 4 times 18 minus 4, 4 times 14, which is 56. So in theory it works. I did a little check. I'm not going to dwell on this because I'm pretty confident, but just so I didn't make any errors, simplify. That's the idea. Now, I've already grouped L plus W. I think I'm going to try and do some sort of quadratic with K. Because I got that, I have that 532 that I have yet to equate this with. But I think then if I put L plus W, I'll call it something like, I don't know, N. And then I have less terms that I need to work with, and then we'll probably have L plus W has to be certain values, and then half of the bigger ones will have to be L and the smaller ones W. Okay. So, with the factor of 4, of course, we can divide by. So 532 is 4 n minus 2k plus nk minus 2k squared, where n is L plus W. And once again, since I've gone over a page, let's just double check because I don't keep notes with me. N minus 2k plus nk minus 2k squared. Okay. So get out trusty calculator, 532 divided by 4, or I suppose I could long division it out, but 133, which is a weird number, n plus n minus 2k minus 2k squared. Let's get that as a single quadratic, so 2k squared, we'll bring it all over, plus 2 minus nk plus 133 minus n has got to be equal to 0. This is true for any of the frames that satisfy 532 is the surface area. Okay. I suppose quadratic formula is in order. So negative b plus or minus, because there's no way I can see to factor this. Square root of b squared minus 4ac all over 2a. And this is quite telling that we have to divide by 4. That will mean certain values of n can be left out, because remember, k's got to be an integer. Alright, so let's take a look at this discriminant in here. So that's going to be 4 minus 4n plus n squared minus 8 times 133 minus n. So that's going to have to be n squared plus 4n. And then 4 minus 8 times 133. So it should be minus 1060. Weird numbers. There's a lot of weird numbers here today. I can't think of exactly where to go next. I mean, this has got to be greater than or equal to 0 to get a solution in here, but then to force k to have to be an integer, where do we go? Also, let's just quickly make sure. So 8n minus 4n plus 4 minus 1064. Yeah, okay. This has got to be a square. So n squared plus 4n minus 1060 needs to be a square number. Is there a limit to the squares that we can have? So n squared plus, you know what, I should have kept this plus 4 here. Because now I can do, this is n plus 2 squared. Minus 1064 has got to be a square. Alright. So there's n plus 2 squared and so on. Interesting, interesting, interesting. Where do we go from here? So n plus 2 squared minus some other square, if we just rearrange, it's got to be 1064. So n plus 2 minus a, this is just difference of squares, plus a has got to be equal to 1064. 1064, tell me you've got some nice factors. You've got 2 to the 3, 133 I'm pretty sure is a square, but let's double check. Not divisible by 2, 3, or 5. It is divisible by 17, however. Or not 17, 7, and gives us 19. Alright. So, if I call this x and this y, x plus y over 2 has got to be equal to n plus 2. Y minus x. I'm going to switch the order then. This one's x, this one's y. X minus y over 2 would then have to be my a. Now it's k is equal to n minus 2 plus or minus a over 4. Now, n minus 2 plus a, well, that's just going to be, so this is x minus 4 over 4, or it's y minus 4 over 4. But then we're looking for either x or y being a multiple of 4. Right, because then x is 4k plus 4, and y is 4k plus 4. Those are our two options here. So x is a multiple of 4, or y is a multiple of 4. Okay. So let's take a look for factors that have the 4 in them. So we can either have this is seeming too complicated for a C part. I mean, we breezed through B part. An A part, is there something I'm missing? Doesn't look like it. It seems like we've come a long way and we're still not really close to answering the question. Oh well. Okay, so we need one of X or Y. So let's just start listing. Y is going to have to be the lower one because we're subtracting A. We'll need to know what K is and what N is. Now, we've only got 3 factors of 2, so only one of X or Y is going to be a multiple of 4 no matter what. So we'll know pretty quickly which one should give us the K and then what the N is. We'll also have 2, 532. We can have 4 and 1, not 133, but 266. We can have 7 and whatever the heck 8 times 19 is, 152. We can have 8 and then 133. And we also have 14 and 4 times 19, which is 76, I believe. Yeah, 76. And what else can we have? 19 and 56. And 28 and 38. It's 1, 2, 3, 4, 5, 6, 7, 8. So 16 factors, and this should be 4 times 2 times 2. So yeah, 16 total factors. So we've got them all. Okay. So now, what will K be? K is X minus 4, so 160 minus, so 160 divided by 4. So that's 265. Here, it's always going to be whichever one's a multiple of 4 minus 4 divided by 4. So 132. It could be minus 4 divided by 4 is 0. That one's right out. 152 minus 4 divided by 4 is 37. 8 minus 4 divided by 4 is 1. 76 minus 4 divided by 4 is 18. 56 minus 4 divided by 4 is 13. 28 minus 4 divided by 4 is 6. All right. And then what on earth is n? N plus 2 is going to be, well, if we divide by 2 and one of the x and y has to be a multiple of 4, if it's going to be divisible by 2, we only need to consider x and y are either both odd or both even. Otherwise, you're never going to get an n plus 2 and therefore never an n. So we can actually cross off this one. Doesn't matter. This one, anything that's got an odd, because we're always going to have some evens. All right. So now 2 plus 532 divided by 2 is n plus 2, so n is going to be 265. K can't be 0, so this guy's out. Eight plus, 133, no, that one's out. Okay. Now, 14 plus 76, 90 divided by 2, that's equal to n plus 2, so n should be equal to 43. And 28 plus 38 divided by 2, that's equal to n plus 2, so here n is equal to 31. Remember, n is L plus W. So we still have to figure out our L and our W. Okay, let's go to the next page. So we've got K can be 132, N, which is L plus W, can be 265. We've got K can be, and now I don't remember the possibilities. K can be 18 and N can be 43. And K can be 6 and N could be 31. Alright. Now, we know L is greater than or equal to W, which is greater than or equal to 2K. So N, which is equal to L plus W, is greater than or equal to 4K. Just add 2 copies of 2K. So that tosses this one out the window, because 3K is more than this. 2K is just a little under, it's one less. 4K, so that would be 72, so this one's out. But 4K is 24, so therefore K has got to be equal to 6, N has got to be equal to 31. So L plus W has got to be equal to 31. Alright, what possibilities can we have? So 2K is 12, and actually W has got to be more than 2K, I said. So W could be 13, and L could be 18. So this is actually going to be a pretty short list. If you were allowed to have sort of an empty equilateral, actually no, you couldn't have an empty equilateral, I keep saying equilateral triangle. You can't have, I was wondering, could I let W be equal to 2K? But no, you can't have an empty prism be taken out because our formula would break down. And so these are our possibilities. Therefore, LW could be 1813, 1714, or 1615. Those are our only possibilities. And there we have it. That C part took a lot longer than I thought, but I guess, I know I complained in the middle of it, but we were actually, I complained around here, and that's because it looked really daunting, but actually a lot of them eliminated because you need N to be an integer, which I didn't properly write down, but you should. And over here, thanks to our calculations, it's quite clear that you're only going to get 1K. That might be explained a little better. And yeah, then we quickly eliminate the other possibilities. Only 3 of them are allowed. Not a terrible question, although I was a little pessimistic and C part seemed a little clunky. I liked the 2013. I think it's a good paper. 2013 Hypatia. And the next that I'll be tackling is the 2013 Euclid. So watch out for that and have yourself a wonderful day in the meantime. So long.